Alrighty, on to our next example. This one's a little bit different because they're asking us to find something other than the speed. It says Melissa was traveling at 50 miles per hour on a concrete road with a drag factor of 1.2. Her brakes were working at 90% efficiency. To the nearest tenth of a foot, what would you expect the average length of the skid marks to be if she applied her brakes in order to come to an immediate stop? So if we think back to our formula, right, our formula is S is equal to the square root of 30 times D times F times N. Here we're trying to find the length of the skid mark, so we are trying to find D in our formula. So that means we have to plug in what we know. The speed is already given to us. It says she's traveling at 50 miles per hour. Say 50 equals the square root of 30 times D, use lowercase here, times F, which is my drag factor, which looks like is 1.2 here. They're always going to give you that, times my brake efficiency, which is 90%, so I'd put it as a decimal. So we say 0.9 or 0.90. I need to solve for D. So in order to get D by itself, what I'm going to do first is I'm going to go ahead and simplify everything that's under my square root. So I'm going to take 30 times 1.2 times 0.9 just to simplify it a little bit. When I do that, I'm going to get 32.4 D. Alright, so I still have a problem. I need to get D by itself and it's under the square root. So we have to recall what undoes a square root. And taking the square of something is going to undo that square root. So I'm going to square both sides of my equation. So when I do that, on that left-hand side, 50 squared is 2,500 is equal to, again, square roots and squares cancel each other out. So I'm just left with 32.4 D. Now this should look a lot nicer, right? To get D by itself, I'm just going to divide each side by 32.4, which tells me that D is going to be 77.2 rounded to the nearest tenth feet. So the average skid mark was 77.2 feet. So just as always with formulas, you can't go so fast where you just plug everything in. You got to think about what they give you and try to figure out what you are trying to solve for. So that's everything on skid marks. Now we're going to talk about a yaw mark. Remember, a yaw mark happens when there's like a curve, right? The car is turning while it is skidding. So those, when we look at those marks on the road, they're not going to be straight, but they're going to have a nice curved shape to them. Here's our formula for a yaw mark, sorry. S is still the speed of my car when it goes into that skid, is equal to the square root of 15 times F. F is still that drag factor. That's the exact same thing. Here, though, R is my radius. A lot of times in these problems, they're not going to give us the radius. They're going to make us find it. In order to find the radius, we have to use this formula here. Talking about a couple things in that formula. C represents the chord length. So if we look over here at this picture, if this is my yaw mark, at the mark left on the road, when I hit my brakes, the C, or the chord length, is my distance between 2 points on my arc. Okay, so here's 2 points on my arc, right here and right here. The chord length is the distance between the two of them. The M is, we call that the middle ordinate, and what that is the line perpendicular to the chord. Okay, or in other words, it's the line that makes a 90-degree angle with the chord. It goes from the center of the chord out to the edge of the arc. I'm probably in these problems always going to tell you what the chord length is and what the middle ordinate is, but I just want you to see what this picture is to see where those two dimensions come into play. So you are going to have to find the radius using this formula here, and then take the radius and plug that into the yaw mark formula. So let's go ahead and try an example. So it says an accident reconstructionist took measurements from yaw marks left at a scene. Using a 43-foot length cord, she determined that the middle ordinate measured approximately 4 feet. It says the drag factor for the road surface was determined to be 0.8. Determine the radius of the curved yaw mark to the nearest tenth of a foot. So we have to find the radius first. So again, I'm just going to write that radius formula for you. R equals c squared over 8m plus m over 2. So if we just plug in what they give us, they tell us that the chord length is 43 feet. So I'd have 43 squared over 8 times m, which is the length of my middle ordinate, which here is 4 feet. Plus m over 2, we said m was 4, so we just take 4 over 2. Just plugging in what we know into the formula. When I plug those things in, rounding to the nearest tenth of a foot, my radius would be 59.8 feet. Great, so we got the radius of this yaw mark that we have on the road. We got to determine the minimum speed. So we have to use our yaw mark formula, which is the speed of the car is equal to the square root of 15 times the drag factor times the radius. So if we just plug in what we know, we'd have 15. My drag factor we see up here is determined to be 0.8. 0.8 times my radius, which is at 59.8. Again, you just plug that into your calculator, take the square root of all of these three numbers multiplied together, and you should get the minimum speed to be 26.8 miles per hour. 28.8 miles per hour. So in order to make those yaw marks, they're saying that the car had to be going at least 26.8 miles per hour. Alrighty, hopefully you were able to follow that okay. What would be a good thing to do right now is pause the video and go ahead and try this next example. Once you think you have it, you can turn it back on and kind of walk through it with me to make sure you did it correct. Alrighty, welcome back. Hopefully you had a chance to try it. Now we are going to try to figure out the minimum speed, and it looks like it's going to be of a yaw mark, not a skid mark. So first, as I highlighted here, you have to find the radius of the yaw mark to the nearest tenth. So again, the radius is equal to my chord length squared. So that's going to be that 46 squared over 8 times whatever my middle ordinate is, which it says my middle ordinate is approximately 6 feet. Right, those are all things that they would measure at the scene when they're looking at the yaw mark, plus my middle ordinate over 2. Rounding to the nearest tenth, you should have gotten 47.1 feet. So that is my radius. Once I have my radius, I can then go ahead and determine the minimum speed of the car. So we say again, S equals the square root of 15 times the drag factor times the radius. Well here, the drag factor is 0.95. So we'd have 15 times 0.95 times 47.1, the radius. Again, when we plug that into our calculator, we should have gotten the minimum speed that that car could have been going when they go into that, making that yaw mark, or when they hit their brakes, would have been 25.9 miles per hour. Again, these are things that accident reconstructionists look at when they're trying to determine maybe who's at fault in an accident. Like I said before, a lot of times they take this information and go to court so that they can say maybe coming in to the scene, based on the skid marks, this person was speeding so then they would be at fault for the accident or something along those lines. Hopefully these videos made sense to you. If you have any questions when you're working on the homework, please shoot me an email. We will review a lot of this again tomorrow, but the worksheet will be due tomorrow. In order to get the worksheet, you must now go show the sub your filled in notes, and then they will give you the worksheet. Have a great rest of your day. Again, shoot me an email if you have any questions.